Thanks, everyone. Given the sparsity of the room, I'm guessing that this question is relevant. So what is Ruby plus OMR? So we'll start by talking about OMR a little bit. OMR is an open source toolkit for language runtimes. It consists of a bunch of components that you can then glue together to your existing language runtime, things like garbage collection, a monitoring system, a JIT compiler. The goal of OMR is one of compatibility. So in contrast to other projects like Truffle and Graal, we don't want to rewrite a new runtime. We want to step in and help your existing runtime get better, faster, and stronger. The goal here is really it's about integration rather than replacement. So the Ruby plus OMR preview is a vehicle by which we've been experimenting with OMR technology in the Ruby language. Now, at RubyKaigi 2015, I talked about this language, or I talked about this project, and as did some of my colleagues talking about the garbage collector. And despite the fact that that was RubyKaigi 2015, that was only 13 months ago. It sounds longer, because it's 2017 now. So what have we been doing for the last 13 months? The answer is a lot of things. So at RubyKaigi, we had tried really hard to get our code open source before RubyKaigi, and we super didn't make it. There's still more things to do. And in fact, our initial contribution got merged, finally, March 7th, by Charlie, right there. Shortly afterwards, we released the code that we modified in Ruby. However, this didn't have the JIT compiler technology because when we did the first drop of OMR, we didn't put up the JIT compiler because it still was going to take some time. In fact, that's what I spent most of last year on, was trying to get to September, where we finally actually did release the JIT compiler technology. So after the JIT compiler technology went open source, we released the JIT technology for Ruby. And then I've spent a little bit of time taking the JIT technology and moving it up to Ruby 2.4. So I've been working on getting up to date so that we can actually build against Ruby 2.4. So today, if you visit our GitHub project, you'll see that Ruby 2.4 OMR is the current default branch. And this is based right off of the Ruby 2.4 tag. The JIT compiler is hooked up and running Travis CI tests. We only run a small set of the MRI tests because we fail make test all right now. Working on that. I've spent a bunch of time populating our issue tracker, trying to make sure that it's clear the state of the project, what we're working on, what needs to be worked on. Just a heads up for any of you who go and benchmark this right now. We're slower than we were in our preview. This is because I've actually turned off some of the optimizations that were hard to justify because they were a little too specific to math and math type things that show up in benchmarks, which isn't a real workload. We're aiming for something that's actually going to be much better in the software engineering layer. So for the JIT, the goal has really been functional correctness right now. We want to pass the whole test suite at all of the optimization levels we're exploring. And as I said, the goal here is integration, not replacement. So we don't put any restrictions on native code. Since the preview, we've added some optimizations and reworked a couple of others. So I have reworked the way that our inliner works a little bit, taking advantage of the new call caches that got added for Ruby 2.4. It's got a very simple compilation control today. It just counts how many times the method's invoked before it compiles the method. And so really what I've built is a foundation. This is the state of the project today, is we've laid the foundation, and now we have to build the house on top. So what's our goal with the Ruby plus OMR preview? Well, our goal is to make Matt change his slides. Specifically, the slide where he called out IBM J9, at the time we hadn't named the project, as a potential contributor to Ruby 3x3. So we want to turn this from a maybe into a yes. Indeed, we actually did help contribute. You know, Ruby 3x3 is really going to be about trying to take the performance forward in big steps. And that's going to probably involve JIT. We have a lot of pre-built JIT technology from OMR, and we think that MRI will be able to exploit that. And what's in it for us is a validation of the OMR approach. We believe that we can take these pre-existing components and turn them into a recyclable toolkit for building language runtimes. And if Ruby's using it, that's proof that we did it. The other thing, and this is the other half of the OMR theory, is that community improvement will be shared by everyone. So today, we already build our IBM JDK on top of OMR. Our build process internally consists of cloning OMR and then building the JDK on top of it. So benefits and improvements that happen in OMR are already being shared by Ruby, and that can continue. Now, December, Chris Seaton posted a tweet. I know of 2 people working on secret Ruby JITs for MRI. I don't find this scary. I think that this is actually an opportunity here. So as I go through my talk, what you're going to notice is that I'm not actually talking that much about just-in-time compiler stuff. Because the compiler technology, we've already got it. It's already there. What really has to happen are changes in MRI to enable the JIT compiler to get better and do a better job. And so this is the area where multiple JITs can collaborate on providing an interface to information to make things better. But having some competition is nice too, because it means that we can actually push each other. And the end result of this is a better result for Ruby as a community, not just for us at OMR. So one of the things that Chris mentions, though, is that, in order to get anything when you're compiling Ruby, it takes a lot of sophistication. And I really agree with that, because in my mental model of where I am in doing Ruby JIT work, it kind of looks like this. We've got a curve that we can start pushing up pretty heavily, but we've spent a lot of time just laying the foundation again. All right, so the title of this talk was Challenges, Highly Surmountable Challenges. So the first set of challenges that I want to talk about are challenges that we have in the community. So Aaron Patterson has this great tweet that I have now used in 2 talks and will probably use in many more because I really like it. And there is no best of anything. And so for us, there is no best Ruby JIT, there is no best Ruby interpreter, there's just what works for your use case. So for your use case, that might be Truffle Ruby, that might be JRuby, that might be Rubinius, that might be Ruby plus OMR, that might be mRuby. But as we try to mutate and work in the VM, we need to make the right trade-offs. JIT compilation is, by definition, a trade-off. You are trading off some of the computation that could be used for your users' tasks and spending it to create native code that will hopefully make things better. But this costs memory, and this is going to cost time before your VM hits peak performance. And we need to prioritize, because we can focus extensively on peak performance at the cost of footprint and at the cost of warm-up, or we can focus a little bit on both. There's a whole bunch of metrics that we could be talking about, and really what needs to happen is that the Ruby community, and this will happen naturally as people just adopt things, but it can be a deliberative effort as well, helps provide benchmarks. So opt-caret, by the way, is a great first start. Opt-caret, though, is kind of weird. It's not what most Ruby looks like. It's very, very CPU intensive, and that's not what Rails looks like. And so it may drive optimization in the wrong direction. Now, I gave a big talk at RubyKaigi about this, so you can go watch that talk. I think we have to have a variety of benchmarks. Opcaret's a great start for a CPU-intensive benchmark, but I also think we need some memory-intensive benchmarks. We probably need a startup benchmark, and we're going to need some web application framework benchmarking. And as I admitted at my RubyKaigi talk, I have no idea how to benchmark a web application framework. That's way outside of my skill set. The good news is I managed to actually inspire Noah Gibbs to go and start trying to do this. And so for those of you who are interested in Rails performance, go take a look at his repo. Leave some comments on his approach. He's made choices with a lot of thought into why he made those choices, and it's worth engaging with him to see if you can give him a hand, make it better. Now, the other challenge we're going to face in doing JIT compilation with Ruby plus OMR is information challenges. And so when you look at a diagram of what the MRI, what MRI looks like when you've added in the JIT compiler, what's really important here are going to be these white arrows here, which are the JIT and VM interface, because JITs are symbiotic with their host VMs. A JIT provides performance, but the VM has to tell the JIT a bunch of information. And so this kind of information can then drive even higher performance. And you've got this symbiosis. So one of the kinds of information that we'd really like to see MRI export is the notion of infrequent event notification. So there's a whole bunch of things that in your typical application might never happen, might happen only at the beginning of your application. These are things like redefining basic operations. So if you're going to redefine fixnum plus or fixnum add, this is a weird thing to do and probably won't happen very often. But if it does happen, I would like the VM to actually tell us. Similar things about like modifying constants, changing the class hierarchy. These unlock new kinds of optimization. We can be more aggressive in our specialization. We can actually start optimizing our calls based on assumptions about what the class hierarchy looks like. If the VM tells us when it changes, we can then adapt. Essentially, the goal here is don't create code for things that haven't happened yet. So I don't want to have to generate code to check whether or not you've redefined plus, unless you've redefined plus. Another challenge that we face in MRI is the way that it does exceptions. And ideally, this would be change the way it does exceptions, but that would be hard for almost anyone. But in the meantime, what we might be able to do is actually just ask the VM to tell us whenever a stack frame could be modified. And so today, when you throw an exception in Ruby, what happens is your C stack gets unwound using long jump, and then you'll iterate down the call frames to the bottom, executing any finally blocks that you encounter. Now, the way that we've implemented the Ruby plus OMR JIT, on that C call stack are your JITted frames. And so when an exception fires, we lose any information in there. And so we deal with this today by just actually restoring all of the interpreter state every time we leave JITted code. And this is costly. It costs us time and memory and code cache to do all of this extra work. What would be nice is if we didn't do that, and we only wrote the code back to the stack when it was needed. And so this is where we need on-stack replacement, the ability to transition from an existing JITted body back into the interpreter, restoring any state that the JIT has hidden away in things like virtual machine or things like actual physical machine registers. And the same principle applies to things like debuggers that are actually going and iterating through the call stack themselves. Any of those need to tell us. Really, we don't want to be executing code for things that might happen. We want to only execute code for things that have happened. And in the case of the JITs typically get their best performance by lying to you about what they're doing. They hide as much as they can until you actually ask for it. We will only actually materialize things when they're needed. So another piece of information that would be nice to get out of the VM is profiling information. So personally, I would love it if I could get the frequencies of basic blocks, which would tell me for a contiguous sequence of Ruby bytecodes, how often has that actually been hit? Or maybe how often has that been hit proportionally to how often the method's been invoked? Or maybe we do that in a sampling fashion, so we only update it probabilistically. These kinds of information, though, are really valuable because they let us direct the optimization inside of the JIT. We don't have to spend time then working on optimizing and compiling code that only gets executed 1 in a million requests. So another thing that would be nice to get is some type information. So if you have a Ruby method that only ever gets called with fixed num arguments, we can generate better code if we know that that's what's happening. And so we would like to be able to speculate on types, but we can't speculate blindly. We need to have some reasonable expectation we're going to succeed here. And the way to do that is type profiling. So there's this problem that we face inside of MRI, which is called the horizon problem, or this is what it was called when Evan Phoenix was talking about it at Ruby Kaigi 2015. The thing is, a compiler typically will only look at one method at a time, and so it needs to be able to see a broad horizon in order to bring optimization opportunities. So increasing that horizon will really help things. But much of Ruby's core functionality is actually written in C code, which is a problem for the optimization horizon. So, one of the original conceptions of Rubinius was this idea of, well, we'll write as much of the Ruby core library in Ruby. And that has been successful for Rubinius at times, but has never really been adopted by the MRI core. They've not been super interested in the idea. In order to address that, Evan Phoenix came up with this wild and crazy idea of what he called lifting the core. And the notion here was, well, LLVM has a JIT framework. LLVM also compiles C code. So let's ship the MRI interpreter with all of its MRI intermediate language and let the JIT portion of LLVM look at the actual LLVM compiled portions and do inlining and things across the C boundary. So I have my own skepticisms about this idea, but if any of you try it, and I want someone to try it, please tell me how it works out. Okay, so rewriting all of core, not going to work. Lifting the core, I would love to see it happen, but maybe not going to work. So what do we have for a solution? So my current thinking on this is that we could try something like this, which is incremental Rubyification of the core. So this turns out to be really easy to do in Ruby because we have what's called the prelude, which is a set of Ruby code that's always going to get injected before the interpreter even starts up. This actually gets compiled right into C code that gets loaded directly. So what we could do is take prelude.rb today and convert it to being a directory, just so that it's easy to reason about, and then put a whole bunch, put implementations in Ruby of methods that are actually interesting and causing problems for us that we use maybe only when the JIT's turned on. Maybe you only use it when maybe you only use it from the perspective of the JIT. You don't actually run that code. There's a couple of ideas. This brings startup concerns, but I think they can be mitigated by using Koichi-san's iSeq serialization stuff. And longer term, maybe we can do an ahead of time JIT solution. I've had some interest in doing that. So now we talk a little bit about optimizations. And here's where I admit. When it comes to optimizing Ruby, we who work on Ruby and OMR are babies. Literal babies. We've got a lot to learn. We've got a lot of things to learn from other projects before we can graduate to doing our own thing. We've got things to learn from Rubinius, JRuby, Truffle Ruby. Other people have done really optimized Rubies. Let's pay attention and listen to the lessons and wisdom they have. There's some challenges in testing a JIT, and this is the big one. This next slide is dense because this is a thing I have feelings about, but I'll keep it short. So JIT testing is hard. The thing is, when you are testing your normal Ruby program and you write your tests, there's a lot of value and enjoyment that you get from having a fast-running test suite and having coverage that you get 100% code coverage with almost no repetition. Every single line of your test suite is perfectly nice and valid. You can reason about your test suite very locally. You don't have to do anything special on the command line. You just run rake test or whatever. Compiler tests are not like that, unfortunately. Often you have to run the code multiple times. This is because the compiler will not choose to compile things until it's necessary, which means that you have to iterate around to make sure that the compiler will actually try to compile something, or you have to have special funky command lines to get it to do things. Compiler tests often require global reasoning. So once you have this idea of infrequent event notification, or you do optimization based on speculation, then you have to be able to reason about when does that speculation fail, what is the impact on that. You're going to have to run many VM instances under different options. And all of these problems end up being the same when we're going to test your gem underneath a JIT. It's kind of awkward. But there is some good news in this world. I actually recently had my own personal hero moment where Benoit Dalloz came along and he fixed a bug that I had opened against RubySpec to allow it to do repetition, and he fixed it fast, like way faster than I thought he did or would. And this is a great win for JIT testing because it means that we can at least run RubySpec under repetition to stress the JIT better. We've got some engineering challenges too. So, one of the big ones. This 309 commits gets bigger every day, causes me increasing levels of anxiety. How are we going to keep up with Ruby core? So some of this can be addressed by just good software engineering. So a long time ago, I spent the time and I built a system that parses instructions.def in order to generate callback code for the JIT automatically. So if somebody changes instructions.def, the callbacks get updated automatically, saves a lot of pain and agony. But there's still a lot more that's needed, and I don't have great answers to some of these ones because some of this is just going to be collaboration that's going to happen with the core. There's also just cleanup that has to happen. The callback generator code that I wrote in Ruby is not very good. It's not idiomatic. It's strange, weird Ruby written by me, who I spend all of my day writing C++. The makefiles in the project also need some love, and I've got links to issues there. There's also some challenges that we have with OMR. So all of OMR, more specifically the JIT compiler portion, has only been open source for 4.5 months. So we're still working on things like improving our interfaces, our integration story. We're building a community slowly but surely. So here's where I say the one thing that helps bring this to my point, which is mentorship. I want to help you guys help Ruby plus OMR. So if anybody's interested in trying to tackle some of the issues here, get in touch. You know, I will write documentation for things that are unclear. I'll help you guide the implementation. I'll answer email. I'll be on Slack. I'll schedule a video chat with you. Like, I really do want to help try to spread this technology and help get people up and running. And so I'm willing to spend some time, because the thing is, at the end of the day, Ruby plus OMR needs community interest to survive. You know, we haven't really put any effort into community building up until now. But going forward, we're going to have to, and we're going to need to get some interest from the community. So my to-do list for the next little while is to start publicizing my mentorship commitment a lot more. I need to start talking more with the Ruby core. I'm that guy in the corner listening right now, but now it's time for me to start actually talking. And I need to start writing some of these changes down that we need to make in the VM, and experimenting and prototyping and getting feedback from core developers. Your to-do list is to give it a try. And when something breaks, and it'll break, believe me, open an issue, because that'll help. And ask me how to help. You know, little things are perfectly appreciated. Even if I've got a typo in a makefile, that's great. Send me a pull request. So for hitting Ruby 3x3, you know, the work ahead kind of looks like this in my mind. You know, yeah, we do have some work that has to happen in the JIT compiler, but a lot of it's going to be VM work. And to reiterate the point I made earlier, the VM work can be shared among competition. So any of this work that you do or I do on the Ruby VM probably can be used again by another JIT implementation for MRI. Thank you very much for having me.
So you have plenty of time for questions.
Oh, good.
So maybe you can already help people to contribute. So have you any questions? It's the time for.
So I saw, like, at the beginning you were saying like it's built on Ruby 2.4. That, so like if you're running 2.3, you can't test it out yet, right? Or you have to move the
Yeah.
version of 2.4.
So we have a branch for 2.2. Oh, sorry, to repeat the question, for those who are interested in trying this out but are currently running 2.3 or a lower version, yeah, you'll have to start using Ruby 2.4 for the newest work. We do have a branch that has an earlier version of this stuff all built for Ruby 2.2, so that can be a start. And things that break in Ruby 2.2 may be fixable, you know, for Ruby 2.4. We kind of don't have the resources to maintain multiple version branches and backport, especially given the amount of change that happened between 2.2 and 2.4. So all development's happening on 2.4 because my goal at the end of this is to upstream it, which means that my goal ultimately is to chase head or trunk. You had a question.
I wanted to ask, in terms of performance, you not really, as you were saying, not really in micro benchmarks, but if I tested it right now, would it be any faster or about the same as MRI or even slower? What's the...
It depends a lot on what you run and how you run it. So fairly simple benchmarks, we definitely beat MRI, sometimes by an appreciable fraction, you know, 50%. In other cases, you will see degradations. This gets into the wibbly bits about how to benchmark, which was my Ruby Kaigi talk, so if you want to watch that, I talk a lot about this. But there's a lot of rough edges here. So I can tell you, OptCarrot, it's pretty much a wash today. We're working on it, but it's not there yet.
Okay. I had a follow-up question, which is not really related, but in terms, one thing that would be make it very easier for the community to test would be if support was added to RVM or some of the Ruby version managers, which would allow
I'm not
easily drivers and things like that.
So the question or comment here is, to make it easier to test, we should add this to RVM or RBN for Ruby install, Ruby build. So if I don't have a public issue about this already, I definitely have an issue here about getting that done. But I've kind of mentally been holding off on doing that until I at least pass make test all. That's kind of my bar been for before I do too much in the way of like, hey, RBN, can you add me as a buildable formula? I wanted to at least pass all the tests.
Thank you.
Other questions?
Which occurs to me now that actually that's probably too high a bar because I do pass all the tests in interpreter mode and the JIT's not turned on until you ask for it. So I need to think about this a little bit. I saw a question over there. No? Okay, I'm hallucinating.
Have you thought about maybe making it a Docker container, like a Docker image?
So we have a Docker container for the 2.2 branch. I haven't pushed anything from the 2.4 branch. It is something we've tried before. People have sort of mixed opinions on doing testing in Docker containers. I believe we did have someone try it out and build a Docker container for us. He built a build container. So I can point you at that. It just has all the prereqs installed.
So why is IBM working on this?
So this is all based on the, IBM's sort of plan for the next little while in runtimes is OMR. It's about how we are going to invest in language runtime technologies. And so OMR needs proof points. And Ruby was a great proof point. We have many others, actually. So we have proof points in Lua, proof points in a research Smalltalk interpreter called Sum++. There are more, and I'm just totally blanking. There's one called... Okay, open source ones. No, but the JIT's not done yet, open. Is it? Oh, okay, never mind. So this tells you how much I know about all of these various other ports because I missed them, because they're happening. Okay.
We have 2 JavaScript and
C Python.
Yes.
Another question. I have played a bit with OMR, and one of the things that really interested me was the tooling that you can get. You can get some of IBM's tooling with it. Are there any plans to make it a bit more available? Because I think you need a license or something like that for the tooling, or...
This tooling, like Health Center.
Yeah, for instance, or...
So most people are getting Health Center through like the whatever tooling and the way we used to get it, but Health Center is actually just an Eclipse project. You get it from Eclipse Marketplace now. So most of those tools are all there just on Eclipse to download.
yes, memory analyzer will read the GC box from OMR and some of the other stuff.
Because I think that's also a very good, it's a selling point that can be, it's what also makes the Ruby different, is that you have, it's easier to debug memory issues and look at heap dumps, because on MRI it's just bad. Thank you.
Any other questions?
I have one. You were mentioning about profiling, that you need capabilities in MRI to have that. Is TracePoint API a good candidate for that?
Maybe. So this is where it gets into the questions of implementation. So we could add sort of a private TracePoint and use that. One of the flaws of the TracePoint, or not flaws, let's not. TracePoints can be fairly high overhead is really the big thing here. And it is possible, if you're asking very, very precise questions, to hand roll something that's going to be much more efficient. But it's going to take more time to do that, so maybe it's better to just go through TracePoints. which is a long way of saying maybe.
Any other questions? Matthew, thank you very much for the talk.
Thanks very much.
So the next